Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on permutation in string. So the problem states that we are given two strings yes1 and yes2 and we need to return true if yes2 contains a permutation of yes1. That means our task is to check if any permutation of s1 exists as a substring in yes2. So for the brute force approach, we would generate all the permutations of yes1 and we'll check if any permutation exists as a substring in yes2. So for this, let's use recursion. I'll return permute and check. I'll pass empty to use it as a prefix and I'll pass yes1 and yes2. Now to implement this, the return type is boolean and permute and check, and the first argument would be prefix. Then let's make this remaining and this would be yes2. And keep this short. Now the base condition would be if remaining length is 0, if remaining length is 0, then we would check if yes2 contains prefix. Then we would return s2 dot contains prefix. Otherwise we will loop over the remaining length till the end. Now we'll check if permute and check in place of prefix we need to pass prefix plus remaining dot caret I, and in place of the remaining we would pass remaining dot substring of 0 till I plus remaining dot substring till I plus 1 and yes2. Okay, if this part is true, then we would return true. Otherwise, at the end after the for loop, we would return false. Let's run the code. Oh, we are simply passing the argument. This is not the method. Let's run the code. Typo. Oh god. Okay, it is working. So we are generating all the permutations of S1 and we are checking if any permutation exists as substring in S2. Now this solution is very slow and it is very impractical because the number of permutations would be n factorial, and this will definitely lead to TLE for larger inputs. So now let's think of an optimized approach where um, where the key observation is a permutation means the same character frequency, and we don't need to generate the permutations. We just need to check if the windows of size s length in s2. So for this we can use sliding window and the frequency count. So here the initially the base condition would be the s length should be greater than s2's length, in should be less than the s2 length. In case if it is greater, we will return false. And now we need two frequency arrays, frequency 1 new int. Since this consists of only characters, let's take size 26, and similarly frequency 2 of size 26. And now for each character in s1 dot 2 char array, let's update the frequency 1 array. So let's subtract character minus a to get the index, and we would update it. And now initially the window size should be minimum to minimum of s1's length, s1 dot length. And now for the first window, it would start from 0 till the window size. And I plus plus. So for this, let's update frequency 2 of s2 dot char at I minus a to get the index, and we would increment. Now we will check if it matches. If matches of, let's implement this later, if matches of frequency 1 and frequency 2, then we will return true. Now let's move to the sliding window part. Now for the sliding window, we would start from window size because we have already covered from 0 till the window size. So now the I starts from window size till s2 length, and now we would update frequency 2 increment and frequency 2 of s2 dot char at I minus window size minus a. Let's decrement this. Now again, if it matches, we'll return true. Otherwise at the end we will return false. Now we also need to implement this matches method, this will return boolean matches. We are passing frequency 1 and frequency 2, let's say A and B. Zero till 26 if A of I is not equals to B of I, then we'll return false. At any index, if it is not equal, then the frequency maps or then the frequency arrays are not equal. At the end, it will return true. That is it. Let's run the code. Oh. It is working. Let's submit it. Okay, it is accepted. So this is a fixed size sliding window, and the pattern used is sliding window plus frequency array. So the similar problems are find all anagrams, minimum window substring, longest substring problems. So you can dry run the code, and that is it for today's problem, and I'll see you in the next one.